Imagine this, a sleek, futuristic aircraft cutting through the sky faster than the speed of sound, so fast it feels like science fiction. Meet the SR-72 Darkstar, a hypersonic wonder that could change the game in aviation forever. For years, the skies have been dominated by incredible machines like the SR-71 Blackbird, a jet that flew at Mach 3, 3 times the speed of sound. But even legends eventually meet their match, and now the SR-72 is here to take things to a whole new level. Breaking the speed barrier, the SR-72 Darkstar Unleashed. The SR-72 isn't just fast, it's revolutionary. Designed by Lockheed Martin's elite team known as Skunk Works, this aircraft is built to reach mind-bending speeds. Officially, the target is Mach 6, which is about 4,600 miles per hour. But recent reports claim that the Darkstar has already hit Mach 9. That's 9 times the speed of sound. At that velocity, it could cross the United States in under 30 minutes. To put it in perspective, a commercial airliner would take about 5 hours to do the same. But why is speed like this even necessary? It's not just about going fast for the sake of it. The SR-72 is built with a purpose: to outpace and outmaneuver any potential threat. In today's world, where air defense systems are growing smarter and more dangerous, being faster than the enemy is the ultimate advantage. The Darkstar's speed makes it nearly impossible to catch, let alone shoot down. By the time anyone detects it, it's already long gone, leaving a trail of sonic booms in its wake. The SR-72 isn't just about speed, though. It represents the future of both reconnaissance and military operations. Imagine an aircraft that can gather intelligence in a fraction of the time it takes today's systems, or one that can deliver hypersonic weapons to precise locations before anyone even knows it's there. The Darkstar is designed to be the ultimate tool for speed, stealth, and power. The world is watching as this marvel of technology takes shape. It's not just a plane, it's a statement of dominance. With the SR-72, the U.S. Air Force is declaring loud and clear that the race for hypersonic supremacy is on, and they intend to win. The Darkstar has the potential to change how we think about aviation, speed, and what it means to control the skies. And this is just the beginning of its story. Engineering marvels, the technology behind Mach 9, the SR-72. Darkstar stands as a beacon of futuristic engineering, merging today's most advanced technologies with concepts that seem pulled straight from science fiction. Its most groundbreaking feature is its turbine-based combined cycle TBCC engine, which is an unprecedented leap in propulsion systems. This hybrid powerhouse is not just about sheer speed, it's about precision, efficiency, and adaptability. The TBCC engine seamlessly transitions between a traditional turbine engine and a scramjet engine. The turbine engine powers the aircraft during takeoff and initial acceleration, pushing it to supersonic speeds. Then the scramjet kicks in, using high-speed airflow to maintain combustion at hypersonic velocities. This dual-mode propulsion system could be likened to having 2 jet engines in one, each designed for a specific speed range. What makes this engine even more remarkable is its ability to maintain stability at extreme speeds. Flying at Mach 6 or even the rumored Mach 9 creates intense challenges in terms of airflow management and thermal control. At these velocities, air molecules hitting the aircraft generate such immense heat that traditional engine components would fail. To overcome this, the SR-72's TBCC engine likely incorporates active cooling systems, where fuel doubles as a coolant, absorbing heat before it enters the combustion chamber. This not only prevents overheating, but also optimizes fuel efficiency, enabling the Darkstar to cover vast distances with fewer refueling requirements. The aircraft's body itself is a masterpiece of material science. At speeds above Mach 6, the air friction generates surface temperatures high enough to melt steel. To counter this, the SR-72 is expected to be built with carbon-carbon composites and titanium alloys, similar to those used on spacecraft. These materials can endure temperatures exceeding 3,000 degrees Fahrenheit without warping, ensuring the Darkstar remains operational under punishing conditions. The futuristic features of the SR-72 don't stop with its engine and materials. The aircraft is expected to incorporate artificial intelligence, AI, for mission management, navigation, and decision-making. At hypersonic speeds, human pilots may struggle to react quickly to changing conditions, such as a sudden threat or a necessary course adjustment. AI would step in, processing data in real time to make split-second decisions. It could monitor engine performance, predict potential malfunctions, and even suggest evasive maneuvers to avoid detection or interception. This integration of AI would make the Darkstar not just fast, but also highly intelligent, capable of executing complex missions with minimal human input. The SR-72 is also designed with modular capabilities, meaning it can adapt to a variety of missions. While its primary role is reconnaissance, it could also function as a strike platform, equipped with hypersonic weapons capable of hitting targets with pinpoint accuracy. These weapons, likely missiles designed to travel at speeds exceeding Mach 5, would make the Darkstar a formidable presence on the battlefield. Additionally, its high-altitude operation, possibly reaching 90,000 feet or more, offers a tactical advantage. At this height, it would operate above most air defense systems, making it almost untouchable. Another futuristic feature predicted for the SR-72 is its use of advanced stealth technology. While the SR-71 relied on its speed to avoid detection, the Darkstar could combine speed with next-generation radar-absorbing materials and electronic countermeasures. This would allow it to evade even the most advanced radar systems, ensuring it remains invisible while gathering intelligence or delivering payloads. The cockpit, or lack thereof, also presents an exciting glimpse into the future. The SR-72 is described as optionally piloted, meaning it can operate with a human on board or autonomously. When flown remotely, the aircraft would rely on satellite communications and onboard AI to execute missions. This flexibility reduces risks to pilots, while allowing the Darkstar to take on high-stakes operations that would otherwise be too dangerous. Finally, the Darkstar is expected to be equipped with cutting-edge avionics and sensors. Its reconnaissance capabilities would likely include advanced cameras, thermal imaging, and even quantum radar systems, enabling it to map terrain, track enemy movements, and gather intelligence with unparalleled precision. Imagine a plane that can detect threats from hundreds of miles away, analyze them in seconds, and adapt its mission plan on the fly. Challenges and triumphs. Building the hypersonic future, developing the SR-72. Darkstar is a monumental task, one that pushes the boundaries of what modern technology can achieve. This isn't just about creating a faster plane, it's about redefining the very limits of aviation. With its hypersonic capabilities, the Darkstar represents a technological frontier where innovation is met with equally significant challenges. Overcoming these hurdles requires not just cutting-edge engineering, but also bold vision, collaboration, and relentless perseverance. One of the most pressing challenges in building a hypersonic aircraft is engine technology. Speeds of Mach 6, or the rumored Mach 9, place extreme demands on propulsion systems. While the turbine-based combined cycle (TBCC) engine is an ingenious concept, creating a real-world version that can transition smoothly from a traditional turbine to a scramjet remains a massive engineering feat. The scramjet in particular operates by compressing incoming air at hypersonic speeds, but controlling this process without causing turbulence or engine failure is a delicate balance. Testing and fine-tuning this engine design have required countless hours of simulation, experimentation, and material research, with every small improvement marking a major triumph. Another significant hurdle lies in managing heat and structural integrity. At hypersonic speeds, the friction between the air and the aircraft's surface generates staggering amounts of heat. Traditional materials would melt, warp, or fail catastrophically under such conditions. To address this, the Darkstar relies on advanced heat-resistant materials, including carbon-carbon composites and specialized alloys. These materials not only withstand extreme temperatures, but also maintain their strength and shape under continuous stress. However, manufacturing these components is incredibly complex and expensive, requiring precision machining and specialized facilities. Even beyond heat resistance, the structural demands of the SR-72 are unprecedented. At speeds of over 4,600 miles per hour, the slightest flaw in the aircraft's design could result in catastrophic failure. The airframe must withstand both the intense aerodynamic forces and the pressure changes that come with high-altitude operations. Lockheed Martin's engineers have had to develop entirely new construction techniques to ensure the Darkstar's frame is both lightweight and robust enough to handle these conditions. Then there's the challenge of communication and control at hypersonic speeds. At Mach 6 or higher, conventional communication systems face delays and interference. The SR-72 must rely on advanced, highly encrypted satellite communication networks to relay data back to its operators or onboard AI systems. Lockheed Martin is likely integrating cutting-edge quantum encryption technologies to ensure that even in contested airspace, the Darkstar's communications remain secure and reliable. Maintaining real-time control of a hypersonic aircraft at such distances and speeds is no small feat, and every successful test is a hard-earned victory. A particularly futuristic hurdle is the integration of AI and autonomous systems. While the SR-72 is described as optionally piloted, its ability to operate autonomously at hypersonic speeds requires AI systems that can process data at lightning-fast speeds. These systems must make complex decisions such as adjusting the flight path, avoiding threats, or optimizing engine performance, all without human intervention. Developing this level of AI is not just a technical challenge, but also a philosophical one, as engineers must ensure the system is both highly capable and fail-safe. The costs associated with the Darkstar are another significant obstacle. Developing hypersonic technologies requires enormous financial investment, with billions of dollars allocated to research, testing, and manufacturing. Lockheed Martin and its partners have had to balance innovation with practicality, ensuring that each dollar spent moves the project closer to operational readiness. Securing government funding and navigating the complexities of military contracts is an ongoing process, requiring both technical and political finesse. However, alongside these challenges come remarkable triumphs. The progress made in hypersonic propulsion, material science, and AI integration represents breakthroughs that will ripple across multiple industries. Lockheed Martin's team has already achieved milestones that were once thought impossible. Prototype engines capable of sustained hypersonic flight have been tested, demonstrating the feasibility of the TBCC concept. Advances in materials have not only solved the heat problem, but could also revolutionize industries like space travel and high-speed rail. Moreover, the potential dual-use applications of the Darkstar's technology are a triumph in their own right. While the SR-72 is being developed primarily for reconnaissance and military purposes, the knowledge gained could lead to civilian advancements such as faster global transportation or space exploration. Imagine a world where a hypersonic airliner could cut the travel time from New York to Tokyo to under 2 hours. The Darkstar is paving the way for such possibilities, proving that the pursuit of military innovation often yields benefits far beyond the battlefield. Revolutionizing the skies. The Darkstar's impact on military aviation. The SR-72 Darkstar is more than just an aircraft. It's a revolutionary leap that could transform the landscape of military aviation. If the Darkstar achieves its hypersonic potential, it will mark the dawn of a new era where speed, precision, and advanced technology dominate the skies. Its development could set new standards for how wars are fought, intelligence is gathered, and adversaries are deterred. But the most significant impact lies not just in its capabilities, but in how it redefines the concept of air dominance. The Darkstar's primary advantage lies in its unmatched speed. At Mach 6, and with rumors hinting at Mach 9, the SR-72 could render current air defense systems obsolete. Traditional surface-to-air missiles and interceptors rely on early detection and precise targeting, but the Darkstar's speed would make it nearly impossible to track, let alone intercept. By the time radar systems detect it, it would likely have already completed its mission and exited the airspace. This speed fundamentally shifts the balance of power in any conflict, allowing for reconnaissance or strike operations deep within enemy territory without significant risk of being shot down. Beyond speed, the Darkstar's high-altitude capabilities add another layer of advantage. Operating at altitudes above 80,000 feet, it would soar above most commercial and military aircraft. This vantage point enables unparalleled surveillance capabilities, providing a bird's-eye view of vast terrains. Equipped with advanced sensors and cameras, it could map enemy movements, track missile launches, and even monitor naval operations from a position of total invisibility. Combined with its hypersonic speed, this makes the SR-72 the ultimate reconnaissance tool, capable of gathering critical intelligence in real time. But the Darkstar's influence isn't limited to reconnaissance. Its potential to carry hypersonic weapons introduces a new level of strategic deterrence. Hypersonic weapons traveling at speeds greater than Mach 5 are nearly impossible to defend against due to their speed and unpredictable flight paths. Mounted on a platform like the SR-72, these weapons could strike targets anywhere in the world within minutes. Whether it's neutralizing a high-value target or disabling key infrastructure, the Darkstar could deliver precision strikes with unprecedented efficiency. One of the most exciting implications of the SR-72 is its potential use in joint military operations. The aircraft could act as a force multiplier, gathering intelligence that informs decisions for fighter jets, naval fleets, and ground troops. Its ability to operate in contested environments and relay real-time data to command centers ensures that every branch of the military has a clearer picture of the battlefield. For example, during a high-stakes mission, the Darkstar could identify and designate targets for stealth bombers or guide unmanned drones to areas of interest, creating a coordinated and highly effective strike. The SR-72 also opens doors to autonomous warfare, where AI-driven systems play a central role in mission execution. As a platform that could potentially operate without a pilot, the Darkstar might integrate advanced artificial intelligence capable of decision-making in real time. This would enable it to adapt to unexpected challenges such as avoiding newly deployed air defenses or changing flight paths to minimize detection. The use of AI could also extend to managing its scramjet engine, optimizing fuel efficiency, and even performing self-diagnostics to ensure it operates at peak performance throughout its mission. From a strategic standpoint, the mere existence of the Darkstar could serve as a psychological deterrent. Knowing that an aircraft exists that can breach air defenses, deliver strikes, and escape unharmed could force adversaries to rethink their strategies. This deterrent effect could prevent conflicts from escalating, as nations may be less inclined to engage in aggressive actions when faced with a weapon that can reach them before they even realize it. Moreover, the SR-72's development has the potential to drive global technological competition. Just as the SR-71 Blackbird sparked a race in high-speed aviation during the Cold War, the Darkstar could inspire other nations to accelerate their hypersonic programs. This competition could lead to breakthroughs in not just aviation but also materials science, propulsion systems, and satellite communication networks. In a sense, the Darkstar doesn't just revolutionize military aviation, it pushes the entire aerospace industry forward. Finally, the Darkstar's legacy could extend far beyond its operational life. Its cutting-edge technologies could trickle down into civilian applications, much like how the Blackbird influenced commercial aviation. The innovations made in hypersonic propulsion, thermal management, and AI systems could one day be applied to commercial planes, making hypersonic travel accessible to the general public. Imagine crossing continents in under 2 hours or sending critical humanitarian supplies halfway around the world in minutes. These are the kinds of possibilities the Darkstar makes us dream of. In essence, the SR-72 is not just a marvel of engineering, but a harbinger of what's to come. It's a bold step into a future where military aviation is faster, smarter, and more interconnected than ever before. The skies will never be the same, and for those watching from the ground, the Darkstar will be a symbol of how far human ambition can take us. The SR-72. Darkstar isn't just a plane, it's a glimpse into the future of aviation and military strategy. With its hypersonic speed, groundbreaking technology, and unmatched potential, It's set to redefine what's possible in the skies. If you're as excited about the Darkstar as we are, don't forget to like this video, subscribe for more incredible content, and let us know your thoughts in the comments below. The future is fast, and we're just getting started.